Regarding the session today, good, yeah, glad to see you here. First, a few words, who am I? So my name is Schneider from Cologne in Germany here. I just arrived yesterday, and I'm a freelancer software developer. Started as a software developer, but got into IT security quite some time ago in terms of penetration testing, security architecture consulting, security DevOps, tool automation in these areas, and reviewing architectures and stuff like that in terms of security. Good. So usually I'm giving some kind of security-related talks and sometimes also workshops at conferences. So the same do I here. But interestingly, the DevOps organization committee asks me, because I'm giving a talk later this afternoon, not spoilering, but that's a talk about security versus agile teams, lots of stuff. And I've been asked by the organization committee to deliver a second kind of session talk and whatever. I said, okay, but I have to prepare a second thing then. And they said, no, it's going to be a slideless kind of thing. I said, okay, that's easy. So now I'm doing lots of demos, everything live. I do have some slides, but I'm not pulling them. It's eventually only one slide, the disclaimer, legal stuff. And aside from that, I try to make everything as interactive and as live as possible, because as the name suggests, slideless, this should be some live stuff. This also means that you get the chance to ask questions. So if you do have any kind of questions, feel free to ask, German, English, whatever you like. I'm trying to answer in English then. And let's make this as interactive as possible. And while there's still a few more coming in, just a quick poll. How many of you are mainly doing development in their day job? Okay, that's 60%. And in terms of ops, someone? Well, it's also 50%. Nice. Security, anyone? Ah, cool. Testing, QA? Less than security. Good. Interesting. Cool. That's a cool mix. So I think we can jump right in. First of all, ask questions. Eventually, I'm going to postpone them to the end if it's something we keep for the Q&A session, so we see. I'm talking about security tools, automation, pen testing, in terms of what can be automated and stuff like that. And that's eventually the only slide. So now it's your problem. So in terms of the legal stuff, don't do these things where you do not have permission, A0. Good. Okay. So regarding security, web security especially, I want to introduce you to some kind of tools, some kind of penetration testing tools that can also be automated in one way or the other in terms of putting them into security build pipelines, whatever you name it, wherever you build your software with or whatever you schedule on some kind of automated fashion. I do have prepared some kind of stuff that I'm going to go through here, and we can see how the time fits, but that should be fine. So first of all, I'm going to introduce you to some very, very small training application. That's the one usually I created this marathon management application for some kind of demos in order to have a test object that I can demonstrate things with, which is very vulnerable in terms of security. So there's no feature within it without a reason, and reason being to showcase some kind of vulnerability. It's also you see I'm not the UI guy because I'm deliberately focused on functionality, which is security vulnerabilities. And you see it's very simple. I'm giving a brief introduction, and then we do some manual things that we have some ideas of what security vulnerabilities are in there. And then I'm going to use more and more tools in a more and more automated fashion that can guide us through finding these kinds of vulnerabilities. And first of all, it's a public part here, so we do have some kind of listing of the marathon disciplines. A full distance marathon, I just numbered my runners to have some test data, not being that creative. You can click on any of those runners, and then you see the profile, including profile picture. You can perform a search as well, so searching for Lars Langloff should yield lots of results here. So this small application is very simple to understand, I think, hopefully. For more, you need to create your own account, which I will do later on. And we can also log in. We do have some accounts already set up. So there's a test account. We can maintain your profile. There's a way to upload or import the profile picture using a file upload or URL import like Gravatar, something like that. And you can also maintain the attendances. So what kind of discipline you're going to attend. Nice. You can change if you want. You can do everything in the public parts. You can change your password. That's all. And obviously you can log out and you can log in as administrator. That's the one who is maintaining the times. So here you do have some kind of way to override the data and also do some mass import of an XML to override the discipline in bulk. And you can also edit every runner also here and override that data. That's quite simple. Change the password, something like that, and augment the search a little bit with some background data being loaded. And log out, back out again. Quite simple. I put all those features in it in order to show vulnerabilities, and every time in a penetration test I find something interesting, I think, how can I fit this into Marathon to demonstrate these kinds of things and vulnerabilities? Good. So now we would like to do some manual stuff. Anyone, any idea? Told you to make this interactive. Yep, okay. So here's the first, second. SQL injection, classic one. Yeah, I'm going to try that. Same here. Okay. It's crying. Yeah, we need to. Okay, so I can do a search for something like last. That's pretty simple. And in case if we do have some kind of query like a SQL query or an HQL query, Hibernate query built with some kind of string, not the usual way, that incorporates the value in an unsafe way, like the search term here, I can search for Lars in a single quote and bam, I get an exception, which is quite obvious, showcasing that it's a SQL exception coming from the JDBC driver. So that's a hit. Definitely I can do the counter proof to do a second single quote here, and then basically it works as designed. That's a good sign of testing. Nice one. We can also have some kind of second SQL injection here, like I'm just taking a look at the Marathon URL. I'm going to zoom in a little bit. You see Marathon equals 2. And that's the skater. I can do the full distance. It's Marathon 0. And the half distance, it's Marathon 1. I could do the same here in a manual fashion. 0, 1, 0, 1. Okay, that's pretty simple. But what's 1 minus 1? Same as 0. I would suggest that it's usually not a valid ID, some error message should be thrown back or something like that. But, well, it's same as 0. That's some kind of clear proof. No, not yet. It's smelly. But in terms of trying to test whether it's something, we can do something more like if it's something inside the in the where clause, for example, where the Marathon ID is incorporated, we could do something like 1 and 1 equals 1, which is 1 and true. So that basically it's quite polite. It's not changing anything. I would expect not a valid ID or something like that. I get the same. I can do the counter proof, and 1 equals 2. It should be then collapsing to 0 rows, because and false doesn't yield any results. And here I see the empty result set. Also a proof using the so-called Boolean blind test, and true, same result, and false, no result. I could also trigger the error message, nice that I get these stack traces, which is bad. That's also a clear proof, but I'm not relying on that. Nice. That's a nice start. So I'm not going into the exploitation. That's more for the training on Thursday. I'm going to focus on finding these things. So we've got 2 SQL injections already, pretty nice, and I think you get the idea of how to find security vulnerabilities. We're going to more later on. It's a matter of testing. It's a matter of trying from the outside on the system, a matter of going back and forth, try and error, adjusting a payload, putting all the payloads into the different fields, request parameters, URL parameters, form parameters, headers, cookies, whatever you like, and checking for some kind of sign, sometimes clear evidence, sometimes not so clear evidence, in order to see whether something worked, whether it's stuck and it triggered a vulnerability or not. Good. So now we've got the SQL injection thing already. Something else. Yep. Buffer overflows. Nice one. Yeah. So I should put lots of data or something to crash it. Something like that. Bam, 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 bam. I'm pasting it, and it doesn't crash yet. So I could do some more fuzzings and stuff like that. I think it's close to be free of buffer overflows because it's written in some interpreted language like Java, running on a system that's doing the memory management fast, but never say never. So it could be something that's definitely usable. Good one. Something else? Yeah. upload of big pictures, whether it's checking the sizes and something like that. Good one. I don't have a big one here. Something else, yeah, in the back. XML deserialization. Yeah, I'm not using Xstream here. I do have slides for that, but not in this talk. So finally I managed to get a remote code execution of Java code within the JVM, of C code within the JVM using some XML. But that's something in terms of the deserialization stuff. But there are other XML stuff to check. Nice. So the lady, yes? XML entity. Yeah, that's something we're going to test later. Yeah. JavaScript, cross-site scripting, yeah, also nice. So, well, why not use the search again? So I could try to do something like searching for a non-existent string, and I see 2 reflections, at least, here. And let's check if some of those reflections are not handling the encoding properly to get something we call cross-site scripting. And this would be a classic reflected cross-site scripting. Then I could try to do this. So here, put my simple markup in that, and I see here it's applied, here it is not applied. So eventually this spot is a little bit different, it is, and it's a little bit vulnerable, it is. Because if I can use the underline tag, I could also use the script tag. Classic one. That's the proof. Hey, my JavaScript in your application, alert 1. Obviously that's not that dangerous, it's just sticking there so that we are able to make a screenshot for the report. Real payloads will be more offensive, obviously. Good, nice one. Also we could try to get a second one because, well, that's the reflected one. So let's go for a persistent one. I can do the login as John. John is a nice runner. He is having a last name of John Jogger, and I could try to do something like that. Put this in my name. So it's also lacking input validation. Save, your data has been saved. Pretty nice. What if now someone is surfing over that user? So let this be John or someone else. If I'm searching for Lars, everything is okay. If I'm searching for John, I see that kind of thing, but it's not triggering. Okay. So let's inspect the response. We got back and take a close look, and here we see, here it is properly encoded, here it is not. That looks vulnerable, but it's inside a quoted attribute here. So exactly that. Why not? Why not go for this and name ourselves that way? That's one of the magic prefixes. Save, data has been saved, do a reload here, and bam, I've got alert 1. Nice one. So that's also some kind of persistent cross-site scripting. So whoever is searching for John, some other runner or the administrator will be hacked in that application's context then. Good. Eventually, finally, we can make another one, a last one for this. So let's take a look at the runner here, and let's take a look at the response. It didn't trigger anything here on this page, so it's looking as usual. If that's the name, well, that's the name. And if we see some, here we see runner first name, last name. In the title, you see the alert thing, not encoded. It didn't trigger. Why? It's in the title. Browsers just don't execute JavaScript there. So what could I do? Close the title. Yeah, just give it another name. Title, opala. Bam, here we trigger it, and on this page as well. Good, nice. So you see it's a matter of checking where goes data in, where goes data out, and sometimes even across trust boundaries, obviously, and also across systems in the backend. This system is accepting data, it's forwarding that to the backend, and that system is doing something with that, displaying, calculating, working, persisting, might trigger. Here we do have a persistent XSS now. Another one, good. And something else we can test. So we have 3 vulnerabilities eventually to show of those over 50 or 100 here inside. Let's take a look at the profile picture. That's also something nice. I could copy that kind of graphic image file here, the address, and have this thing displayed here. Here I see it's having that kind of URL, photo loader, and a photo URL parameter is pointing to that kind of default picture or whatever it is. Any idea? I don't. It's a file. So what should I do? Give me a payload. Absolute path. The classic one. It's unfortunately empty. Sorry? Relative path, yeah. So I think you think of going up something, like one folder, yeah. Okay, no, doesn't work. 2? Neither does that work. 3? Eventually also, let's go. What if you're sticking on the root path of a Linux server and go one step above that? You're still on the same root level, obviously. Can't go beyond the uppermost folder. So better use more than less. Here we are. Okay, it's not the etc system. Otherwise, I wouldn't show that to you. etc shadow, I think. Good. Great. So that we can now see how this finding thing works. We did some manual stuff right now, yeah. Lots of stuff inside. If you're really having fun with these kinds of things, attend the workshop on Thursday. Then we are doing these things. Cool. But now I think it's more in order to go to some tools. And I've prepared something here. I'm just glancing on my iPad to see what I prepared in order to show that to you. So now I'm going to introduce some categories of tools to you. And as promised that I don't have slides, then basically I write my stuff here. So we have, in terms of checking for security issues, we do have 3 categories of tools, 2 major ones and a third one. So the major ones, DAST and SAST, they stand for Dynamic Application Security Testing and Static Application Security Testing. That's actually the fun part. DAST, Dynamic Application Security Testing, which was what we did right now. So we're testing on a test system with permissions. Cloud provider also agreed, etc. And we're trying to put malicious payloads into that and see some evidence, or check for some evidence. Simple things here, but it's basically the same story no matter how difficult the payload is. And that's checking from the outside and getting evidences of successful findings. And SAST is checking from the inside, Static Application Security Testing, which means code scanning, source code or bytecode analysis, trying to find vulnerabilities from within, actually, by scanning code. And it's also something that we do have tools in that area. And what should you use? DAST, SAST? To be honest, you should use both. Because some things can only be found or better be found using DAST, checking from the outside, the real system. Some things can be better found using SAST, checking from the inside. Just to give you 2 examples. Dynamic things like checking for the SSL, TLS, cipher config on the load balancer. That's something that really makes sense to do from the outside, and also check for some headers and leftover stuff. Doesn't make any sense to use static code scanning to find these things. On the other side, if you do have some bad crypto in your backend, when you're encrypting something in the database and you reuse some initialization vector, or you're not using GCM or something like that, that will, in terms of bad crypto, that's something that the code scanning tool will find. There's no way for a DAS tool from the outside to find that kind of thing. So you should go for both. What about this little friend? IAST, it's more newer in that arena. It's standing for Interactive Application Security Testing, and it's a way trying to combine these 2 things. Some people can refer to that as dynamic code scanning as opposed to static code scanning. It's interesting because it's the benefit that we are running our code in some kind of interpreted language environments, like the Java JVM usually, or the .NET CLR, or some other things like that, where we do have a runtime environment that's interpreting bytecode. Bytecode is similar to source code for these tools. So it's not that we are running actual machine code. We're not compiling to the processor. That means we can have some kind of tools that are able to take some inner views and augment also the runtime environment on a test system to inspect for security issues. And the general approach is something that I'm pretty sure you're quite familiar with, which is using some agents on your JVM or on the .NET CLR or whatever your runtime environment is, like profilers or source code coverage tools, testing coverage tools. Those are agents, or simple debugger can be seen as something like that. So it's something that you put onto your test system from the outside to get some inner workings there. And in the profiler world, you get some nice hotspots where your code is slow and where your memory management is not good in terms of leaking stuff. And we can also do some security checks there. So there are also tools existing that can do some inside view in terms of augmenting, instrumenting your deployment unit or your runtime environment using some Java agents or .NET agents. And then when you're using the application from the outside, they are checking from the outside how the data flows through your layers and tiers, and also from the inside using the bytecode instrumentation. Very nice thing. And now I want to give you some more tool demos in that area. And that's something we can do quite simply. And more or less in those two areas, because here we do have some open source tools. I also use commercial tools, especially in those areas. They are also very good, but they are sometimes very expensive. Not all, but many. And it's more for the enterprise corporate world to be purchased on a corporate level, not on a project level. And I want to give you some kind of open source tools that you can use just right away. So I'm focusing on open source things, and that definitely right now rules highest out of the game, because here we only have expensive commercial ones. Good ones, but commercial, expensive ones. Not against them, but well, it's not something I'm going to show you right now. So you can ask questions for those tools later. I'm now going into the DAST thing, which is exactly what we did doing from the outside, going back and forth, testing things, doing some kind of interpreting of the response, whether something's stuck or not, and worked or not. And we do have tools in that area, and these tools in that area are something that we call intercepting proxies. Anyone heard about that? Use it? Oh, just a few. Yeah, the security people. Great. So in the intercepting proxy world, we do have some kind of HTTP, HTTPS proxies. So they are usually focusing on anything that's web related, or some web service, REST, so backend, whatever, or web application, but not focusing on classic TCP/IP protocols and stuff like that. This can be done in a similar fashion, but different tool set. So for the web thing, we do have intersecting proxies, commercial ones, free ones, and I'm going to use the best in town open source one, which is from the OWASP, Open Web Application Security Project, non-profit organization for web security. OWASP.org is the homepage. Good stuff there. And one of the major tools they do have is OWASP ZAP. ZAP is the best open source intercepting proxy. It's something that can be called the Pentester's IDE. And I'm going to open this little friend, looks like that. And yeah, we do have a UI, but this can also be executed headless, just spoilering what's coming next in terms of full automation. Here we do have some kind of Pentester's IDE. It's like a weapon, so you definitely must be sure that you understand how to configure it to not shoot into your own food and into someone else's food without permission. So that's something that should be used with some caution, but it's something that's very useful. So it can be run in a very simple way. Just I started it here, and it immediately spun up a proxy server, a HTTPS proxy server. It also generates a custom self-signed certificate for proxying HTTPS, which I can then import into my trust store, because I expect this as a pen tester. And then I can see the traffic that my browser is generating proxied through this tool, like a browser console on steroids. So let's check in the options what kind of proxy port we do have. I changed this to something free on my machine. So I can configure any kind of web client. This could be my browser, which I'm going to do in a second. Can also be some rich client, some desktop application that's accessing a web service backend. Then I can proxy that through this tool as well. Or I could also expose that kind of proxy port on the Wi-Fi, and then I would eventually use a tablet or smartphone and put this in the same Wi-Fi and change in the network settings that the HTTP, HTTPS traffic is sent through this kind of proxy. I have to play a little bit with the certificates, sometimes eventually overcome certificate pinning for a few apps, but feasible, and then you can get the background traffic of those apps in order to attack this. But we are focusing, as said in our training application right now, on the web browser, and I changed the proxy configuration right now to go through this Zap thing. So what I see now is that every click here, I'm bam, still my payload in it. Okay, so put back harmless. So every request I'm executing is sent through this little friend here. So we do have a history. That's like the browser console. I can click on any request, and then I see the request in question here in full detail, full beauty, request response, just looking at it like in a browser console. We do have a way to see the requests already observed here in that kind of sitemap tree, which is dynamically built, so you see some kind of background traffic of my browser. And the Marathon application, obviously. You can do way more. It's having a poser mode, show all tabs, but I'm focusing only on the majority of the features, and in terms of the security relevant part of that. And usually these tools can do two ways of scanning. They can perform two ways of scanning: active and passive, or passive and active. Passive scanning is non-invasive by design. That means it's just not doing anything harmful. It's just watching the traffic, observing it, and getting some idea of interesting or security relevant insights from watching the traffic. So usually you don't find the high-hanging fruits that way, or the high-value vulnerabilities, but you do find some bad things in terms of headers not really good, or cookies not hardened, the easy-to-find stuff. And this is done because it's so non-invasive, as it's passive by design when started. And it's something that we can check right now on the Alerts tab here. We see some kind of headers that are not quite good, or cookies are not hardened. So yeah, do you have cookies that are not really good, or headers are missing, or some headers are not set. So that's something that's like a second pair of eyeballs. Even those error messages that I managed to trigger. So here using that single quote, bam, I get the stack trace information disclosure. And this is something that eventually, here it is, application error disclosure, also fits into that. That's pretty nice. But passive scanning, as said, doesn't find the major vulnerabilities. Couldn't be. But benefit of that passive thing is you can run it on every commit. So you can execute Zap in a headless way, do this later, and do just the passive scanning. That's the first step you can take. And whatever kind of test automation you have, user interface test automation, or some service tests, or whatever, just proxy that through Zap in passive scanning mode, and you get first insight without risking anything. That's as easy as that. It doesn't slow things down, not risking stuff. But now we want to go more into the active scanning thing. The nicer thing, and this is something that should be done, must be done only on systems where you do have explicit permission, including the operations people, asking them. And if you do run stuff in any kind of cloud, you have to ask the cloud provider, and that's okay. And then you can do the active scanning. And active scanning is actually something that we did. So it's permutating input vectors. This is the URL parameters, form parameters, headers, everywhere where we want to shoot against, where we can provide untrusted data, with permutating that with payloads. And the good tools, they do have many payload signatures and testing for many different vulnerability types. And basically they are reissuing the requests many times. So if you are going to attack one request, it's executed multiple times depending on how many form fields or how many URL parameters you have, and depending on how many payloads you want to test, how your scan configuration is, and stuff like that. Good, so I can do a single manual scan using that tool. Let's go for the classic one, the runner search here, search for last, bam. Let's do the classic one which is not triggering anything, just search for last. And now I could do something like, that's the request in question here, and I could do right-click on this single request, attack active scan. So given that we do have permission, which we do, I can configure some kind of scan policy. I'm not going to this right now. I just hit start scan. And now it's permutating different payloads, 500, 600, 700 kinds of things. With this search request, and it's through. And I do have on the Alerts tab now a few more interesting findings. I do have a SQL injection, so that's found automatically using that kind of tool. Also, I do have a cross-site scripting, the reflected one, we already had this here, result of searching for. So it put this script tag into the payload. Here you have a short description of what the attack actually means, and here you've got the request and response. Nice. So this was one active scan of one request triggered manually right now. Good. So now I want to go more into this kind of thing, and also to try to configure it a little bit, show you how this can be configured, and then we go to more automated scans. So first of all, you can do some kind of configuration, like configuring how quick the scan is in terms of how fast requests are executed. So you can configure the concurrency level here, for example, or the delay, if you want to have some delay between each shot, that you're not risking some kind of overload of the server. That's something that makes sense. And also you can do some more configurations in that regard, as well as where the data gets into the system. So you can configure what kind of targets should be shot at. So here you do have URL parameters and form parameters as the default. Makes sense. Well, that's where the user data gets entered. And if you do happen to have some kind of REST API with path parameters /customers /12345 /orders, then that 1, 2, 3, 4, 5 thing is actually some kind of dynamic parameter, then it might make sense to test path elements as well. So you can click that checkbox here also, or headers, whatever, if you have custom cookies that you're going to process further. And you can define excludes here, so it doesn't make any sense to scan a JSession ID for some reflections or injections. Well, that can be easily, and that's the default already, omitted here. And you can have some built-in input vector handlers. That means you can have some kind of built-in formats that this little friend understands, and they are all on by default. That's okay. And here you see XML and JSON. That's pretty nice. That's how awesome those tools are. They understand automatically if it's an XML or a JSON request, and what they do is they put then their payload into each and every attribute and element of the XML, and also into each and every attribute of the JSON. So it keeps the syntactic request structure intact, in order to eventually trigger in the processing later on some kind of vulnerability. That's pretty awesome. So you can use this to automatically scan using some REST interfaces or some SOAP web services. You just need to put some traffic through these tools, and they will automatically attack it. They understand these kinds of syntax, XML and JSON. Pretty nice. Not only those form field stuff. Good. This also can be scripted and extended very, very heavily. Just to give you an idea what can be done, you can have some kind of plugin that you can install here. There's a whole marketplace of plugins. So I installed the advanced SQL injection scanner plugin. It's a nice one. But you can get some more scans. You can write your own ones if you like to. That's pretty nice. And you can also configure a scan policy. And now it's getting into what you're really trying to achieve. So a scan policy can be configured, and that's basically a way to define how strong basically those attacks are, how your risk appetite is, and also when the tool should talk about it. So how certain the evidence should be in order to be a valid finding in the report. So it's a matter of what you're going to achieve. So here I for the injection attack, for example, for SQL injection, just to have some demo, I set the threshold level to low. This means basically they are set to the default, which is medium, and that's worst of both worlds. So if you, and we are doing this in the remaining half hour, later are executing this in a very automated fashion as part of build pipelines, and you're automatically breaking a build on some high value, high risk, high severity findings, this means you're automatically stepping on developer team's toes. And this means you're automatically getting some kick in the back. Basically, it's backfiring. Pretty certain on that. That's from the experience tools. And it's in terms of these tools also do have false positives. by design. That means tool thinks it has found something, but reality check is, well, that's not a thing, it's a false positive. Well, nice try, but that didn't work out. And when you're breaking builds on false positives, I tell you what happens. When you do have a sprint and you're going to release on the evening, then after release and the tool breaks a build, then the development team says, well, this kind of security scanning tool just broke the build. And usually it wasn't something very critical, and sometimes also false positives. So we have to release this evening. We just temporarily turn this kind of thing off, never turn on again. So here I really would recommend to turn the threshold level to low, which means, to high, which means that for those automated scans, you only get those findings in the report and in the build breaker criteria that are really something where the tool is quite certain it has found something, where the evidence is quite strong. So then the build is broken less often, but it's fixed more often because it usually was a thing. If you do the triage manually, so if you do the filtering out and sorting out and analyzing false positive or not in a manual way, I would recommend to set them all to low to get more findings and tolerating more false positives. So it's a matter of what you're doing. And the strength, that's basically the risk appetite and the time you have. So how many different payload combinations should be run through this, how risky they are, and how many iterations, and that means how long the scan would take. So I just configured a little bit the turning up the SQL injection scans. So we see lots of SQL injection scan attempts later on due to this configuration. Everything is here totally optional. So all those configurations doesn't need to be done. It's just that you do have the way to do this. Projects, by the way, here can be persisted, so ZAP sessions can be saved so that you can pre-configure stuff and later spin that ZAP up from a pre-configured session to retain your configuration settings and stuff like that. Pretty nice. Good. So now we had some kind of configuration things. So I would like to introduce more the automated way of using this tool right now. And that means we need first to have a way to have it either automatically understand how our application works or get some traffic. And all those DAST tools, dynamic application security testing tools, they do have some kind of crawler mode. Here it's a quick start mode using a crawler or spider, and basically they are all not good. I don't recommend them. It's what you're trying to achieve. Are you going to be compliant or secure? If you want to be compliant, put your URL into this, and you can check off, did some scan, and what did it find? Well, not so much, yeah, okay. But if you want to get security, it means you have to do a little bit more than just put the URL in and the application is fully scanned. This doesn't cut. Because those tools, those crawlers, they do have at least one out of three, or even more, eventually a combination of those three problems, the typical crawler problems. And they are first JavaScript. So if you do have a very JavaScript intense on client side, intense application, some crawlers might simply bail out. They are not getting all those background requests. Just an extreme example, single page HTML application, and I've scanned it, and what did you find? Well, it's just index HTML, and the background request, nothing. Second problem is with those crawler order. Just simple things like first put the product in the shopping cart, then proceed to the checkout, not the other way around. Doesn't make any sense to proceed to checkout with an empty shopping cart. How does the tool know? Or third is just business data. So if you have to enter a valid IBAN or SWIFT or any address that is a valid surviving an address check, then basically some scanning tools might fail. So they are not providing the correct data to go to the next step of the wizard. That means all those crawlers, they do have lots of white spots. But there's a solution to this, and all those, the commercial ones and the free ones and the open source ones here, those tools, they do have some other way to operate. And that's something we call, or I call in that area, scan as you serve. The tool vendors call that differently, but that's individual to the tool. I call these things scan as you serve. And that means that we just configure the tool to be in a mode of operation where it's automatically attacking every newly observed request. Then we just need to have something that is requesting. So we need to have some kind of test driver. And if we are in an agile world, we need, and if we are doing some agile software development and doing lots of releases, more or less automated using DevOps technologies, we should have some kind of test automation. Otherwise, we do not know whether we are doing a good or bad release in terms of functionalities, in terms of technical correctness and stuff like that. So usually we should have some kind of request generating automatism already there. Otherwise, we will simply use some kind of intern to do some kind of traffic on the browser. But usually this should be automated already in our teams. So we can just reuse this kind of Selenium tests or REST interface client tests or SOAP tests, whatever you have. So you do have some kind of code that is generating traffic to test your system. It's generating the correct requests in the correct order with the correct business data. So you're overcoming all those obstacles. The only thing you need to do is proxy this through ZAP, or any kind of intercepting proxy, which is pre-configured to run headless in an scan as you serve mode. And then, due to the configuration, every newly observed request is automatically attacked. That means all those different input vectors are automatically scanned with the different payloads. And this is something we're going to do. As promised, slide less, but well, I think picture says more than 1,000 words. We do have some kind of slide for that. Let me just check in my different slide decks which slide I'm going to show you for this. Here it is, that one. So we should definitely go for something like putting ZAP in between some kind of automated tests. So you do have some CI jobs generating, executing some build scripts, could be Jenkins, Maven, Gradle, whatever you do, executing service tests or executing Selenium or other kind of UI tests using a WebDriver. And this HTTPS traffic against your test system is proxied through ZAP, and then it's basically communicating back the results. And for this we do have headless mode and REST API. Yes, question? That's a good one. How much extra time would that take? Basically, it depends. It depends on the amount of request parameters or the input vectors, so how many targets are for that kind of request, and on the configuration and how long a request takes in your system. So it could be way more or could be just a little bit more. So I wouldn't recommend to do this on an on-commit basis. No, I would do this at most on a nightly basis, because it might take a little longer depending on your different kinds of requests and the configuration. We'll do this right now. Good. Okay, so if you do have questions, feel free to ask. Good one. And now I think you got the idea of automating these things, and I'm quitting my ZAP. Everything live to have a fresh restart. And here I'm just giving you a little bit of CLI command line interface stuff. So here you see it's very good configurable on the command line. We do have a way to give it some config files, to give it some kind of session. So that's basically the project we could save in order to respawn our configuration, configure the port and stuff like that. So we even do have a Jenkins plugin for this. We do have a Maven plugin. We do have a official Docker image with the ZAP. So that's pretty simple, pretty nice. Good. So now we've got the help, and also there was something. I didn't show that. There was something sitting here, which is to start in daemon mode. Yeah, without a UI. Java AWT headless equals true, something like that. That means you get some kind of way to start ZAP pre-configured, pre-seeded with something in a headless way. But I'm not now starting it again with some UI, because otherwise the demo would be quite headless. But I'm not using the UI to do stuff here. I'm just using the REST API. Which REST API? This tool does have a built-in REST API. I'm going to show that to you as well. Here we do have some nice fully fledged API. Usually it's that way with some random to the machine, static to the machine, random API key. For the demo, I just, for the sake of the demo, disable the API key so that I can do it without any API keys. Otherwise, lots of copy-paste going on. So this kind of thing is already running the API on a port, and I can then basically, it's the ZAP port actually, to which I configured the kind of thing, and then I can use browse API. And that way I get here the API. I just better use it inside a browser that you see more. Zoom in here. something like that. Here you do have the welcome page of the ZAP API, local API. That's pretty awesome. And here we do have some components. That's basically the business areas of ZAP where you can do configuration with. And you can do all the different configurations you can do in the UI and trigger the different actions you can do in the UI using that kind of API. And in order to do it in a fully automated way, just imagine it would be spun up headless. I'm just showing the UI that you see how it works. And you can do lots of stuff here. So configuring it, already talked about that. And one, that was totally optional, but one configuration should be definitely done. That's a child protection. So in order to not shoot around the internet, in German we call this Kindersicherung, basically so that you need to have some outer boundaries defined here where you do have some kind of configuration of where the tool can shoot at and everything else should be not touched, not attacked. Otherwise, your browser or your kind of application client might generate some other requests. Just imagine that in your browser, you see some stuff from Facebook or Google or whatever, and then bam, those are shut down again using your IP address. Bad idea. So this might make sense to define the outer boundary. And this is something in ZAP, which is called context. Context. Default context here we do have already. I just double click on it to show you how it would be done in the UI. Default context, including context, and here you can enter a regular expression of the URLs that are attackable. I'm not doing anything here because I'm in headless mode, but that's basically how it can be done. And now we want to do this using the API. Just open the context thing here, and all those components, they do have views and actions to read data and do something, getter, setter, whatever. So here I can do and execute the REST API interface, including context. And that's basically, I would enter the API key in a third form here, but I disabled the API key for the sake of the demo. So I'm not needing to, going to paste the API key here. And here I can do a post, I'm changing something, and I'm assigning the default context. You can name them, and I'm just using the default context, which is the one and only default one. And I'm assigning to that a regular expression of what should be in scope. And that's pretty simple. I just use my localhost 8080, where my marathon application is running, .star, which means any character after that. Including context, okay. Could be done using a curl script. That's pretty simple. That's part of your build. Just one command line interface. And now I do the cross-check, double-click, and I see, indeed, I do have a localhost entry here. So that kind of thing worked. So that way you can also debug your kind of REST API usage of ZAP, and if it really works, you can then spin it up using the headless daemon mode. Good, so that's for the context. And the other thing we need to do is the so-called scan as you serve mode. Which is that? Or what's that? The scan as you serve mode is a mode which is automatically, as said, attacking every newly observed request parameter, and I'm going to do this. In the UI way, I would simply set this to attack mode. No, every newly observed request is automatically attacked, so all the different parameters are permutated with the payloads, but I'm not doing this using the UI. I'm doing this using the API. So just going back. And this is something, I think it's sitting in the core module. And here we see views and actions. Set mode, here it is. That's perfect. So it's a very good REST API. And we set it into one of those for the drop-down box. Now I use the attack mode. And when I now hit the set mode button, you should see on the top left corner the standard mode changing to attack. Works. Now the weapon is loaded. So basically it's sitting in attack mode. Every newly observed request is automatically attacked. Would be done headless. And we set the default context, which is our marathon application, on the test system here on localhost. So now all I need to do is to do some kind of surfing. So I need to generate some kind of traffic. Reuse your Selenium scripts, reuse your service tests, make it eventually a little bit with a different parameterization, a little bit slower in terms of not being too fast, because every step, the ZAP tool is queuing, no problem, but the queue builds up and it's permutating all the requests, so it might make sense to be a little bit slower. We can do this. And definitely try to ignore all those assertions, because otherwise the outcome would be definitely not expected one. So clearly separate this run from the technical or functional testing execution of your tests. So don't mix these two things. But on a direct execution of security checks, then the assertions should be ignored, because data would not be the expected kind of data. Just imagine you're creating a entry somewhere, and then ZAP is creating 500 entries after you, and then the total amount is 501, not the expected one. And also don't hit the logout button. So if you do have some kind of authentication, don't at the last step do the logout, because ZAP might still be in the scanning mode, and then when you log out, well, you know. Good. So we will do this right now for the next last 10 minutes. So I set this into attack mode. I set the context, so this little thing should work. Let's make it using a little bit of window foo. So I try to open up my log file so that we can see the blood flowing here. Then I make this a little bit less UI blocking here over this. We can then take a look at the alerts tab, for example, where those findings are. And then we can put this little very secure thing here. Let's do it that way. I think that's good. Okay, so now I just start from the start page. And here you see already some kind of traffic being generated, interesting one. I click now on a marathon. You see some kind of exceptions being generated here. I can do a search for Lars. And you saw already some payloads in the search field due to the sessionness. And some findings are appearing here in the bottom. So I can click on the Lars requests here. So the photo is also loaded. Back on home. Do it on the skater. Click here. And now I click on this link. Do a little bit more. And we can wait. We can wait and wait and wait. And we see some more and more traffic in the log file being generated. That's some exceptions due to the payloads. And we already have some findings. Nice one. SQL injection, cross-site scripting, path traversal, stuff like that. And we can even go beyond that and do a login. So I just log in as John. And now I'm doing I'm submitting the save here, the form, to just seed that kind of request with all the different form fields. So lots of stuff to attack, might take a little bit. And then I'm constantly reloading the profile just for the fun of it, that you see how my name changes. So I turned the SQL injection tests to high, so we should see lots of SQL injection tests going on. And but the other ones are also checked, and we should see some interesting names permutating flowing through those form fields here when I just hit save, and now I'm just reloading. And here you see different kinds of payloads being there for different kinds of attack vectors. So it's a matter of try and error, of going back and forth and checking the evidences of valid findings. As promised, lots of SQL stuff due to the high level I tuned there. And that's basically the way it goes. Nice. Nice, nice, nice. While I keep this running, any questions? Okay, yeah, one. How do you cope with CSRF tokens, cross-site request forgery tokens? Yep, those little friends that are preventing some kind of attacks, very good one, and also preventing some kind of automated scans. The good DAST tools, the good DAS tools, do this automatically. So does ZAP. You can even configure them here. So it's for each try, each shot is using the token from the response before that. Good one. Okay, so now so far for this kind of thing. So this could have been done totally headless. I didn't do any stuff in the UI here just to show you that we do have some findings. Now I want to take the report. So I could use the menu here to execute or export the report as HTML, XML, or something like that. But as said, we're doing this in a fully automated way. So we do this using the REST API again. So here we do have some kind of report stuff. So let's check. I think that's also in the core thing. And here exactly we do have alerts and alerts summary. Let's use alerts summary as one request. So doesn't need to be parameterized by a base URL. I just can get a subtree reported there, but I'm going to use the full report. And the summary is just this: high, low, medium, and informational. That's the build breaker criteria. So if you define that something is high, that makes a broken build, or medium, that makes an unstable build, that's where you should go after. And if you want to get the details, you've got basically numerous options, but two interesting ones here. And you can get the alerts in detail. That means you can then get for subtree using pagination, so from 1 to 10 I'll count in terms of how many, but I'm keeping them all empty here. Or for a certain vulnerability type, only the SQL injections, no, give me all alerts, bam. And that's basically in JSON what I got back, or I could do it in HTML, also nice, or I could do it in XML if you want to do it that way. So okay, it's not rendering here, but it's the XML thing. And also you can generate, this can be used to automatically process the results in one way or the other. And you can also do some kind of report artifact generation, the same as would be in the menu here, using another kind of API. So that's basically, I think it's an action inside the, yep, here it is, inside the core area. And here we do have HTML report, JSON report, or Markdown report, and or XML report, obviously. Let's do the HTML report, and then you get the same full report here. A little bit more beautiful. So here you see those SQL injections that have been found, where they have been found, using some descriptive text here also, how to fix these things, linking to those OWASP information about how to fix stuff. The cross-site scripting ones, including the evidences for that, and the SQL injections here in more detail. I think the path traversal here, that's the path traversal. That was the request in question. Photo loader, photo /////etc passwordy. Nice one. And that's pretty awesome. So for a simple scan, it's just a matter of spinning up the tool in a headless way, eventually seeding a pre-configured kind of session file if you want to, in terms of how deep the scan should be, and then just use the REST API. It can be done using the official Docker image, and then use the REST API to using one or two curl scripts to set this to attack mode, to set the outer boundaries, and then you need to drive it with some kind of traffic. Nice. Good. So, any questions about this friend, how this tool executes? Yep. Yeah. If you do have a false positive, the question was, which is showing all over again, can it be muted? Yes and no. So when you, depending on what you do with the result. So usually these results, if you have to happen multiple projects that are executing scans like these, using more tools. This was just one part of a full tool chain that can be used in terms of security, DAST, SAST, IAST. Then you have multiple reports, multiple outcomes, and that means you have multiple truths. And that means you need to go for one, and that's basically funneling all those different tool outputs into some kind of vulnerability repository. Some kind of server you do have on-prem, obviously, which is storing and deduplicating and consolidating all the different kinds of findings from the different tools. And we do have commercial and free open source, including from the OWASP, vulnerability repositories that can understand the native output formats of all the commercial and free scanners. And that's basically where you put all the findings in. These vulnerability repositories, they do have outgoing interfaces towards bug trackers. They can create Jira tasks for that, and in those vulnerability repositories you can flag them as false positive, so they are no longer showing up in the bug tracking systems or something like that. Nice question. Yep. New vulnerability types. How often is the tool updated? Yeah. Also, it depends on the open source community. That's a good baseline thing, definitely. The scan engine is good. What's really excellent in ZAP is, aside from being free and open source, is the REST API. As you saw, it's really Awesome. We do have commercial tools in that area, and even not so expensive ones, that are better in terms of scanning, the gold standard, but they are not yet that open that you can include them so easily in a fully automated build chain, but they are going into these directions. So, and they are updated then due to the subscription model more often. So I would recommend to use the free tools and start with that, and then you can go and think where you need more commercial tools. Yeah. Yeah, last one. On my business card, so if you do have more questions, you can also fetch a business card here. My PGP key is on it, and my phone number and my email address, or PGP public key. And I'm doing pen testing. So basically, I would be going out of business if that would be everything. So no, that's basically the thing that I recommend to have the baseline check in an automated way. Benefit is of that it scales. So that means you can use it as part of your build pipeline. You can use it in your security regimen in all the different kinds of setups. And then on some kind of security indicators, could be great changes of the application's code, or very sensitive stuff that has been changed, permission stuff, or some kind of big releases, whatever. Then you do need to have manual pen test. As a pen tester, you also use tricks and techniques that cannot be automated by tools, because it's in terms of understanding the business logic, finding business logic fails, and in terms of security. And also some more high-hanging fruits that a tool cannot get clear evidence of. But what really disturbs me in my daily pen testing work, which is highly manual work, is to find all the things and all the default findings that these tools would have easily be found. And that's something that I recommend to use them. Good. So due to the time, I think we are to the minute through. So if you happen to have any more questions, I'm still here in the room packing my things. Here's my business card if you want to get in touch with me later on. Otherwise, I say thank you, and hopefully the live demonstration were quite interesting, and have a nice rest of the day. Thank you.